Welcome everyone to our Traffic Signal Techniques to Support Network Operations Planning webinar. Our presenter today is Dr. Ian Espada. Ian holds degrees in Traffic Engineering and Transport Planning from the University of Tokyo and Asian Institute of Technology, as well as in Civil Engineering from Central Philippine University. From 2001 to 2008, he worked as a transport planner for Almec Corporation. Ian joined the network operations team at the Australian Road Research Board in 2008 and is currently team leader for that team. He's also a lecturer on transport demand modelling at Swinburne. My name is Rosemary Patterson and I'll be your moderator today. Next slide, thanks Ian. The webinar will run for approximately 30 minutes with 15 minutes for questions. And you will see in a moment on your screen the webinar functions. Please use them to interact with Ian and me. We'd love to hear your experiences, so please share them. The chat function is there for you to type into, and the raise your hand function is to be used if you have a technical issue. Ian, it's over to you now, and I think you're starting off with a bit of background on traffic signals. Let's hear all about it.
Thank you very much, Rosemary. Good afternoon, everybody. It's afternoon here in Melbourne. Today we're going to be talking mostly about the materials of the recent update of the Guide to Traffic Management Part 9 of LOSA Traffic Operations. This new guide, which was recently made available online, covers a few items. These are on your right on the screen. Some smart motorways. There's a lot of material that provided on the management of motorways, such as ramp signals and so on. The second one is on traffic signal techniques and network operations planning, which is our key topic for today, and some references to cooperative ITS and some specific items on pedestrian protection, pedestrian push buttons, single point urban interchanges, diamond diverging interchanges, bicycle detection, and so on. There's a lot of material that has been updated in the guide. However, for this particular presentation, we will be focusing on one particular aspect, which is the traffic signal techniques to support network operation planning. The key references involved in this webinar are the following. The first one is the one published in 2015 and also its research report entitled Signal Management Techniques to Support Network Operations Planning, which are the main source of information of this webinar. The Guide to Traffic Management Part 4, Network Management, which deals with the network operations planning, movement in place framework, level of service. And the third one is a 2015 report which looks specifically at the level of service metrics that are suitable for network operations planning. And also there is a online resource from the SmartRoads website called SmartRoads tool, which is a relevant tool to be used in the application of network operations planning. In this webinar, these are the key concepts that hopefully by the end of this session you'll be able to at least have a good understanding. The first one is the movement in place framework, the network operation planning framework, the level of service, traffic signal techniques, and impacts. Now, we may not be able to go in detail each of these key concepts, but I'm more interested in really in tying these concepts together, hence the title of this talk, Traffic Signal Techniques for Network Operations Planning. Yes, Rosemary.
Ian, sorry to interrupt. We've had a few people having trouble getting in, so we're asking them now to try again. We've reactivated something that wasn't working. Thank you for trying. Thanks. Over to you, Ian.
Should I begin?
Keep going. Yeah,
keep going.
Continue. Thank you.
All right. Let us then start the story with this slide, key issues, which really encapsulates why we're doing what we're doing. Urban population growth is increasing, as everybody knows. So this brings about new challenges in the way we operate the network. Pedestrians are now a very important, have emerged as a very important consideration for the operations of the network. So is public transport priority. Tram signal priority, for example, was one of the seed or one of the original problems that was solved or attempted to be solved through this particular framework. So public transport priority, we want to support sustainable modes of transportation. Hence, we need to be cognizant of the needs of the public transport vehicles operating on our network, which requires a different set of functionalities, different set of requirements as opposed to the traditional general traffic consideration. The other one is the place aspects. So we need to be, we have started to recognize more fully the role of the roads and its functionality to support broader community goals. So for example, if it's a tourist area, we need to operate the roads as such to support the tourism aspects. If it's a retail area, we also need to support that. If it's a school and so on. The other very important road user is freight. These heavy vehicles also operate in a different way than general traffic. So we need to be cognizant of their slower nature, lower acceleration, larger footprint, time sensitivity, and access requirements. So we need to be able to operate the network to also support them. Then comes the vulnerable road users. These vulnerable road users also play a very important role, and they have very special requirements. Safety is obviously a very important consideration for these vulnerable road users. So while we have these now more complex and very varied and often conflicting road user requirements, we also have the issue of burgeoning congestion. Our cities are getting more and more congested every year, and I think we are at the point, at least in Australia, many cities, in capital cities of Australia, we're at a point where we're reaching near saturation. So therefore, every additional incremental increase of general traffic will have catastrophic or significant impact to congestion levels. So in that context, then, how do we actually operate the network? So that's the key challenge here. And obviously, traffic signals, there's more than 12,000 traffic signals in the whole of Australia and New Zealand. And these traffic signals is probably our primary weapon to operate the network. So how do we actually operate these traffic signals in this particular context? Now, obviously, when we're dealing with these more very broad considerations of road use functionality, we do have a lot of stakeholders in this particular game. So to be able to move forward, we need to be able to set the rules. We need to have a framework such that consensus building, the responsiveness of the treatments that we apply become much more effective. So one of the cornerstones of this said framework is the movement in place framework. And it's a very simple concept, yet very powerful one. In the x-axis, you can see here is the place function. So to the right, stronger the place function. And the y-axis is the movement function. Now, we can then therefore divide this plane into quadrants, and each quadrant will have for example, a strong movement function with a relatively weak place function, or it could be on the other side end of the spectrum where it's a very strong place function, such as these cafe streets. Then you have these residential access streets. Then you have also the high movement function, which is more of a high-performance arterial or even a motorway. Then you have complex interactions with where there's a place function, at the same time a heavy movement function such as a primary arterial running through the CBD. So what that means then is that if we recognize each link in the network to belong to any one of these quadrants, we can then designate certain functionalities that we are supposed to achieve. And we don't achieve everything. We don't attempt to achieve high mobility and high place function at the same time. So it allows us to prioritize and target specific functionalities as opposed to solving the global congestion cost. So we can then be more responsive to the place function as well as mobility function when it is required, or perhaps more accurately, when it is agreed upon by the stakeholders. So setting the rules and setting the functionality requirements, setting the rules on which part of the quadrant each link will belong to, and setting the functional requirements when it belongs to that particular quadrant is the cornerstone of this movement in place framework, and it helps us along the way to solve these very complex and varied functional requirements of the various road users. And ultimately, in the context of traffic signal techniques, help us select the proper traffic signal techniques to use. So just to further clarify this concept, we can think of this particular quadrant, this high movement function, low place function quadrant, and perhaps the functional requirement for that particular link would be to target improved travel times on vehicles on moving corridors and motorways. Hence, the prioritized customer group would be cars, heavy vehicles, public transport, on-road public transport, and motorcycles. On the other end of that spectrum, if a link is located in a high place function with very limited movement function, hence we would prioritize pedestrians in that movement. Now, all that seems very intuitive. However, what that means is once we get all the stakeholders to agree to this set of rules, then it's very easy then for the traffic signal engineers or traffic engineers to be able to design the appropriate measure. Now, this is one specific example of such rules that I was talking about. This is the SmartRoads tool example. So in a particular, these rules will have a certain place function, so activity area level 1, 2, 3, and 4, wherein a level 4 is actually a strip shopping center. Now, if it's located in the pedestrian primary network, then these rules will then govern. These arrows dictate what level of encouragement should be accorded to that particular road user, in this case a pedestrian. So in this particular example, I circled one here, interpeak. During the interpeak, we have strongly encouraged pedestrian movement in a strip shopping center, which means that the we would then be supportive of the lunchtime activities, the retail activities during the interpeak period. Now, if you look at the general traffic in the same activity area level number 4 or strip shopping center during the interpeak, you can see that the level of encouragement for general traffic is to encourage local access only. Now, that's one specific example. Different time periods will have different levels of encouragement for each mode of transport or each road user. So what does that all mean? What that means is that we can assign certain levels of service for each levels of encouragement. So in this particular example, the strongly encouraged levels of encouragement should reflect a level of service of a requirement, whereas a encouraged local access only would only require a level of service D. Now, this A, B, C, D here is quite related to the highway capacity manual levels of service. However, it is interpreted in much more broader sense. What it simply means is that at level service of A, you should provide the best operating conditions. Well, and then level C and D would be like moderate levels of qualities of service, and then in F, it goes to F, then it would be a failure at that stage. So in this particular example, since we're dealing with pedestrians, we can have a definition of level of service A per pedestrians, wherein pedestrians experience minimal delay in crossing. Whereas at level of service D, general traffic can experience up to 2 signal cycles to clear. Now, since we set the rules in terms of defining the link classification, the movement classification, and the place classification, which ultimately dictated the functional requirements, we then have a very clear set of guidelines in how to select the proper traffic signal operation for this particular link. So we can then calculate what we call as the operating gap, and that operating gap is simply equal to the difference in the target, or the target level of service, or the required level of service, and the current level of service. In this case, we say assume that the level of service for cars at the current situation is level of service E, and if you multiply that by the number of car users, then that gives you what we call as an operating gap. The same thing we can do with pedestrians. Since it is a strongly encouraged for pedestrian, then if the current level of service is C, then level of service A minus level of service C multiplied by the number of pedestrians give us the operating gap for pedestrians. Now what this means is that then if assuming the roughly equal number of pedestrians and car users, then we can clearly see the pie chart of the operating gaps that is much more problematic for pedestrians. Even if you can consider that in a traditional sense, perhaps we may be dealing more for the general traffic, because a level of service E for general traffic is level service E. So in traditional methodologies, we may deal with the general traffic more. However, in this particular methodology, particular approach, we can actually see that we'll probably be focusing more on the pedestrian issue. So because that is more suited to the agreed operation objectives of this particular link. So once we have that, we can then consider a different set of traffic signal techniques, one that which is much more pedestrian friendly, and we can consider things like double or half cycling, reduced cycle lengths, or fixed demand, which targets more the pedestrians rather than general traffic. Okay. Now, going now to the traffic signal techniques. The traffic techniques in the Guide to Traffic Management Part 9 provided some guidance, some very good guidance in terms of classification of traffic signal techniques. So the traffic signal techniques, there are various types of them. Some were classified for general traffic improvement, some were for public transport, some for heavy vehicles, some for bicycles, and some for pedestrians. Okay. Now, I'll give you some examples. Now, in the Guide to Traffic Management Part 9, we categorized and we identified, through the help of traffic signal operators in jurisdictions, we listed as much as we can traffic signal techniques that are supportive of general traffic movements. Examples are in your screen. So I'll just rattle off a few specific examples. So first one is improved signal coordination and progression. So coordinating the offsets between different signals to improve progression of general traffic will improve the delay, reduce the delay. Banned right turns to prohibit right turns to improve the through movement. Skip right turns, so skipping right turns every second cycle to improve through movements. Or maximum time transfer or stealing. So although each phase has only one maximum time setting, the maximum time of a given phase can be increased by transferring maximum time from other phases. This provides an automatic method of adjusting the relative allocation of maximum time where traffic flow is particularly particularly tidal. Gating, controlling the inflow and outflow of traffic to prevent serious congestion in sensitive areas where it is particularly important. So these are some of the examples that are available for general traffic, and here are the traffic signal techniques for public transport. I'll mention a few. So the first one is green extension or phase extension. So traffic signal extends green period when a bus or tram is approaching to assist with clearing the signalized intersection prior to the red period. Recall or red truncation, where a bus or tram is expected to arrive prior to a green phase. The red phase is terminated early, and signal phases are reconfigured to allow the green phase to begin earlier. Okay, that's just a couple of examples for public transport. Next one is heavy vehicles. So these examples are longer signal cycle times. Longer cycle times generally favors truck movements as long as the green time ratio is maintained. Longer cycle time typically can provide a longer green period in a cycle, which allows more vehicles, including trucks, to pass through and approach irrespective of truck's position in a platoon. Longer cycle times also minimizes the need for trucks to stop and start. So since trucks are more sensitive to stop-start operation, having signal cycles that reduces the probability of stop-start movements would be favoring heavy vehicles. Another one that is very important one is coordinating signal offsets for heavy vehicles. So selecting offsets to minimize trucks from stopping on an arterial road is very effective for trucks. As we all know, these offsets are typically designed using general traffic passenger car operations in mind. So typically these slower heavy vehicles will have problems going through the design progression because of their slower speed profile. Bicycles. So having these are some of the examples of traffic signal techniques that support bicycle operation. So the first one is late start for vehicles. So bicycle phases started prior to parallel vehicle phases. An early start positions cyclists where they are most likely to be noticed by motorists when a parallel vehicle phase begins. Typically, the vehicle late start would only be activated if bicycle is detected. Another example is the fully protected parallel crossing for cyclists at shared path crossing. So green bicycle signals are displayed concurrently with the operation of a green pedestrian signals at protected parallel shared path crossing. Typically, the cyclist or pedestrian on a shared crossing would be required to press a call button to activate the crossing. So, and finally, pedestrian phases, pedestrian traffic techniques. So exclusive signal phase for pedestrians, so simultaneously preventing vehicle traffic on all intersection approaches from entering the intersections to allow pedestrians exclusive crossing access. Another example is an exclusive scramble crossing. All this quite very similar to the previous one, except that diagonal movements are allowed. Or double or half cycling in areas where traffic signals are coordinated and there are high pedestrian volumes. A minor intersection or mid-block intersection may use a cycle time that is half the length of the adjacent signal. So as we all know, the cycle time is pretty much dictate the crossing delay of pedestrians. So you can see that we through this in this few slides we have listed and categorized various traffic signal techniques and what kind of road user they are supporting. So the next consideration is then how do we actually do we have some guidance in terms of the impacts of the traffic signal techniques. The Guide to Traffic Management Part 9 and the 2015 OSTRO's research report also conducted a review and consultation of the various traffic signal operators in all jurisdictions to develop some high-level guidance. Now, this high-level guidance is obviously each case has to be assessed on its own merit. So there will be case-specific issues that need to be considered, but at least if everything is in the absence of any other information, this guidance can provide a starting point on assessing the traffic signal impacts. Now, I'll just give you one specific example. Each of the traffic signal techniques that were showed earlier has a particular rating in terms of their impacts, both for the road users traveling in the direction of the treatment and impacts for road users traveling in conflicting directions to the treatment. One example is this public transport priority phase with queue jump lane, and this is one picture illustrating this particular treatment. And you can see here that the plus signs, it goes to 3. So from 2 pluses to 3 pluses, it will assist the mobility of tram or buses, as the case may be. And as you can see also that there are also potential negative impacts to the other road users using these particular intersection with the treatment. So this is an important point, because this guideline, and in particular the network operations planning, we are also concerned about the winners and losers in the treatment. So we're not just interested in terms of the global or the total reduction in, or total improvement in performance or level of service, or total reduction in congestion cost, but we're more interested perhaps in terms of who gets the benefit. So this traffic impact table that you have here in the Guide to Traffic Management Part 9 provides that. So here you can see that certain road users for this particular will benefit from this treatment, but at the same time we recognize that it's a zero-sum game in many cases, particularly in congested situation, and therefore there will be negative impacts to certain road users. Now, whether that is suitable or not will have to be gauged based on the desired functionality of the road. So this goes back again to the earlier point in terms of defining the functionality of the road. So if this road is designed or designated to be public transport priority, then such a particular treatment would make sense. And having a consistent framework would allow more coherent application, more responsive design of traffic signal operation. So in closing, let me just summarize some of the key points here in terms by contrasting a traditional approach versus a network operation planning approach. In a traditional approach, typically the idea is to reduce the total cost of congestion, global reduction in congestion cost, more in terms of improving efficiency. However, in a network operation planning context, the focus is on alignment with desired link functionality. So in that particular case, in the public transport priority example that I showed earlier, we are not much concerned with the total reduction in congestion cost. If we can achieve reduction in congestion cost, better, but we are more interested in designing the operation for a particular road user depending on community expectations. The second one is that we tend to focus on one mode in a traditional sense. However, in a network operations planning approach, we try to understand the trade-offs across modes. We understand that we cannot be dealing with one mode at a time. We need to look at the whole spectrum of impacts to various road users for each particular treatment. The other one, the other point is the emphasis on mobility in a traditional sense. However, in a network operations planning, we begin to emphasize the place function, because really roads are not just for supporting people from going from point A to point B, but also they are a place for people to congregate. It is access to tourism places, to retail area, to all these other community activities that are very important, and therefore we need to recognize that these roads are not just for through movement, but also they need to address the place function as the livability aspects as well. So having that, we would then open the understanding of traffic engineers, wherein they would be able to open up and deal with these issues much more directly. So it's not just about improving delay, but also looking at what you're supposed to do. The other point is there's a possibility of conflicting operational objectives in a traditional sense. However, in a network operation planning approach, because of the development of this framework of link in place, movement in place, designing with an agreed set of rules in terms of assigning levels of encouragement, we have more chance of having a more coherent operational policy. So if we have designated a particular route as a public transport priority, that will be consistently applied throughout the route, and having that, because the rules will apply to various parts of the network, the same set of rules. So therefore, there is more likelihood of a coherent operational policy in a network operation planning sense. So, that concludes my presentation.
Awesome. Thank you, Ian. And we've got a couple of questions. Are you able to take them?
Sure, yes.
Our first one is from Eleanor. Thanks, Eleanor. Are any of the states and territories using or considering green waves as used in Europe, USA, Canada to provide through movements for cyclists leading to higher LOS?
Once again.
Any of the states and territories using or considering green waves as used in Europe, USA, Canada to provide through movements for cyclists leading to higher LOS?
It has been this green wave for bicyclists was a suggestion from one of the states. So at the very least, I can say it's being considered. Whether it has been implemented, I'm sorry, I cannot answer that question. I don't have that information.
Awesome. Thank you. Thanks for the question. Thanks, Ian. Gordon says he's wondering how the new NOP software supports this aspect of NOP.
You're probably referring to the SmartRoads tool. So yes, the SmartRoads tool supports this initiative in terms of linking traffic signal techniques to network operation planning. However, the current tool is being upgraded right now, and one of the things that is being upgraded through another OSTOS project is to create a library, and this library would include things like the guidance on possible impacts. So and then also in terms of providing a list of traffic signal techniques that will support particular road user levels of encouragement. So right now it's 2 steps removed, but in a year or in a year and a half we should be able to upgrade the tool so that it's much more tighter integrations, just 1 step removed, and wherein the tool will become more user-friendly and much more of a planning decision tool than what it is right now.
Awesome. Another question about what's happening overseas compared to what we're doing. Any possibility of implementing 2 vehicles per green each lane at ramp signals across Australia, which is being trialled overseas? Thanks, Wayne.
Yep.
Read it again.
Yeah, I'm not familiar with that concept, so I don't think I'd be able to answer it confidently. Yeah.
Okay. Thanks, Wayne. We've got heaps of questions, which is great. Vivek asks, will the boundary of the place function, is it restricted to intersection only or to some distance from the area?
If you're talking about footpaths, and definitely the area definition is a geographical area, so it extends beyond. It's a contiguous area, and if so happens the link is located in that area, hence it is classified as such. The definition of the place functionality of a particular area is based on a set of rules. And these rules are, first and foremost, have to be agreed by the stakeholders. The issue here is that when, for example, in the case of a strip shopping center, when do we designate an area to be a strip shopping center? Now, would it require 2 or 3 retail areas and so on and so forth? That has to be first and foremost agreed upon and later set the basis for this particular set of rules. An interesting consideration is future land use. So whether the network operations planning and traffic signal techniques would be able to support a future land use development is also being considered and is actually applicable as well. So it becomes a much more proactive. So say, for example, if you want to promote a certain area which doesn't have a lot of shops yet, but it is intended to be more of a shopping area than what it is at the present form, then this kind of approach would be applicable as well.
Okay, thank you, Ian. And I forgot to mention that any questions we can't answer or we can't get to, or that are a little bit more complex than we can manage today, we'll try to respond by email. We've had a good question from John. Do you consider treating disabled as a separate group?
There is a different, an extended form of network operation planning, which is called accessibility-based network operation planning. And what that does is to examine the levels of service at the root level. So because the disability issue, disability access issue is pretty much the weakest link in the chain issue. So therefore, we cannot assess it on a link-by-link level, and hence the root level needs to be applied. So that kind of framework is available. In fact, we have SmartRoads has done some pilots and research in that area.
Awesome, thank you. Some great questions coming through, and Teresa asks, Smart Toll a free access software from VicRoads, and then she says SmartRoads tool, she means.
Yes, yes, the SmartRoads tool is freely available from the SmartRoads website.
Awesome. So they don't need direction to get there, they know how to find it.
In my very first slide is the website that supports, that provides this tool. Let me get to it. Yes, on the rightmost is a screenshot of that web page, and not only is the tool available, the SmartRoads is also providing technical support. And the current project, the SmartRoads project NS2003, is doing a roadshow at the moment as well in terms of visiting jurisdictions to discuss about the network operations planning in general.
Awesome. Mohammed asks, is there any correlation between managed motorways and this network operation planning framework?
To some degree, yes, but in a relatively limited sense. From the simple thing that there is really no place function in a motorway. So in the movement in place framework, motorways are high on the movement function, 0 on the place function. So in that sense, the priority in a motorway is really for a movement to happen. There is, of course, possibility wherein where there are cases where you introduce, for example, certain priorities on ramps. So, for example, there could be a heavy vehicle priority access to ramps, or it could be a public transport priority access to the ramp signals. So it could form to determine whether certain ramps will have to be provided, queue jump lanes, or more dedicated, for example, use of the shoulders for taxis and buses, so on. These kinds of consideration, in some sense, would be related to network operation planning.
Great, thank you, Ian. Fantastic. Philippe asks how you would recommend to implement the NOP approach in inner urban renewal projects.
Okay, that's a very interesting area, wherein typically the smart roads or the network operations planning has really been applied in mature networks and congestion, and hence the more urgent need, I suppose, in terms of managing the short-term issues. However, in greenfield development, in urban renewal development, and the like, the vision of road use, the vision of the land use can be provided with support from a particular signal technique. I think I mentioned this case earlier, wherein there could be future consideration of the land use, and this tool can then be applied to be more of a proactive rather than a reactive, provide proactive recommendations as opposed to reactive considerations.
Great, thank you. And Paul asks, can public transport activity define place in context of movement/place?
Yes, each jurisdiction has their own style, you can say, in terms of defining what place is. So, for example, in Queensland, public transport interchange is a particular place function. So, in that sense, if the transferring from bus to rail and so on would require good pedestrian support, then that will be considered. So one way to do that is to designate, in one particular example in Queensland, they have a designated place label called public transport interchange.
Awesome. And we're just getting close to our final questions, Ian. Can you explain whether there is an economic and environmental assessment consideration to the traffic signal operation planning to NOP?
Not right now. Perhaps there is discussion right now in terms of broadening the considerations of network operations planning to focus not just on mobility. Traditionally, it has really been focusing on mobility aspects, but now the livability index, the livability considerations, the amenity considerations, and the safety considerations are also being considered. I suppose the stakeholders in network operations planning are proceeding cautiously to this issue, because one of the positive or the benefits of the application of the smart roads is its simplicity. Because of a very simple framework and very simple application, it opens up more people to use the tool. The moment we introduce something more complicated, like introducing safety, perhaps safety is all right, but introducing environment, economic, to some degree economic is already considered, but amenity and so on, then the tool becomes, the framework becomes a bit more complicated. And whether it defeats the purpose of having that simplicity is something that is an open research challenge. How do we actually preserve the simplicity of this framework while introducing more complex considerations?
Awesome. We'll finish up with this question, which is from Peter. The reduction of operational gap seems to rely on a step improvement in level of service. Are operational tweaks expected to achieve this?
It depends on the definition of the level of service. So I know, I perhaps can imagine what they're thinking about in terms of tweaking the the traffic signal lights tend to focus only on like a 5% improvement in congestion delays, say for example. So hence, it is not a very, it wouldn't be shown here. However, we're probably talking more in terms of structural changes to the traffic signal techniques. So for example, introducing public transport priority or really changing the offset based on heavy vehicle acceleration characteristics rather than the general traffic. So this will involve much more wholesale structural changes. The refinements should be done operationally outside of this particular framework, which will probably be the handcrafting, which is very important as well, but may not have that significant change in the overall structural level of service.
Awesome. Thank you so much, Ian, it's great to have such wisdom in the room, and people have asked some very interesting questions. Thank you so much for the time that you've put in preparing the webinar and in making it so clear and with lots of explanations, and that's your contact details there, and we'll also respond to people who've asked questions and may not have had them answered. I think one came in quite late, and we've had a few thank yous, so thank you to those people who have taken the time to write. Thanks again, Ian, and thanks so much to our audience. We'd like to thank you for being so engaged in our presentation, and please take a minute to fill out the survey that will launch shortly so that we can make sure we're always improving our webinars. Thank you, Ian.
Thank you very much.